Next is, how do we add vectors? So usually, they don't act alone in space. It's composed of a lot of vectors. It's just like the weather news report. You could see the vectors being represented by wind patterns, or even the possible path of a typhoon. But those vector, for example, a path will not just be a path, but if it's not combined with other possible contributions of other vectors. Example, guys, we want to determine the forces, because this will be your future topic. Let's say we have a ball on top of a table. Now you want to determine, and then you want to determine where will it go if there are two forces acting on the ball. For example, you have a force, there's a force going there, okay, and that's a vector. So let's call that vector 1. That's, let's say that's the second vector, F2. And then let's just start with simple addition of vectors. As you can see, there are two vectors acting on the ball. One that is going to the right, that's F1, and the other is going to the left. Obviously, I intend to draw the magnitude of second vector to be lesser than the magnitude of F1. So the consequence of the interaction of the two vectors would lead to a resultant vector. The resultant vector will now have its effect on the motion of the ball. But that would, again, that would be our future topic as we discuss laws of motion. But the point is, there will be a resultant vector between F1 and F2. If we are going to add F1, since we're dealing with vectors acting along x-axis only, so it's one-dimensional setup, F1, let's consider the direction of F1 to be positive because it's pointing towards the positive, it's x direction. And then we have to add, because F2 and whatever the resultant vector F, let's consider that as FR, where FR is the resultant vector, or it's the sum. When I say sum, it's the answer of addition, right? It's the sum of vector F1 and vector F2. By common sense, without having a formal understanding yet of a vector, we could say that FR would have the tendency to be in this direction. But we have to prove that mathematically later, right? I'm just showing it to you, the one of the uses of vectors. And in this case, we're now entering the topic of adding vectors. So how do we add vectors? This is just one way of adding vectors, but this deals only with vectors along a single dimension. Let's consider a much more generalized adding vectors, but we will, because it's very difficult to draw in three-dimensional space, so we will just have to limit addition using geometric approach vectors along plane. In this case, let's try to limit xy, but you may choose if xz or yz. Most physics books or even your math books would just simply consider a plane to be xy. Okay, so for example, so you have xy. Okay, so this is x-axis, y-axis, and then let's have a vector a, and then let's consider a vector b. Okay, that's our vector b. Now we could determine the component of vector a along x-axis to be this much, and this would be ax, and then along y-axis, its projection is a y. Now, for b vector, you have also its component along x-axis, and you could consider that as b sub x, and this would be b sub y. If we want to add the two vectors analytically, we could represent we could represent vector A as AXI because it's along x-axis, and that's the unit vector, plus AYJ hat for vector A. For vector B, this is equal to B sub X I hat plus B sub Y J hat. In this case, if we want to determine A plus B, A plus B, AX, ako na lang i-rewrite guys, AXI plus AY sub hat J hat plus B of BXI hat plus BYJ hat. This is analytical. This could be done geometrical. So in general, I just want to add this. In general, sorry. If I have a component along Z, I could do this. K hat. And if I have a component along Z, I could have, sorry, this is B sub Z, K hat. AZ, K hat plus BZ, K hat. So adding this now, you could get AX plus BX. Common factor is I hat plus AY plus BY. Common factor J hat plus AZ plus BZ, and the common factor is K hat. That is basically your vectors A plus B if it has both has components on X, Y, and Z. So in general, as you could see, A plus B is just the sum of the components of the two vectors. It means you analytically you could add vectors without using geometry by simply adding the components. And earlier we talked about how to determine the components of each vector. If we say that vector C, now I'm introducing a third vector, as I introduced earlier with, if you can still remember when we talk about forces earlier, this one, I introduced a third vector, R. Here, I introduce a third vector and just call it C, and that's A plus B. This can be considered as C sub X, I hat. So that's the component of the third vector along x-axis, which is just the sum of the two plus cy j hat, and you can determine the value of c sub y by adding the two components ay and by plus cz k hat. So that's how you describe your third vector as a sum of vectors a and b. Let's add now vectors in two dimensions. By this, we could use geometric approach. First is using the parallelogram. Let's add this geometrically. How can we do that? If we have, again, as I said, we're just dealing in two dimensions. As you can see, vector C is given by A plus B, but we limit now our consideration in two dimensions only. AX plus BX I hat plus AY plus BY J hat. You have to determine AX. This is the length AX. Here, this is B. From here to here, your BX is, if you're solving this geometrically, you have to use a ruler. You add the same length of B and add that where the A ends. That's the meaning of this expression. You have now AX plus BX, and then you have also AY, and then you add BY. This one. This is AY, and then I have to add BY. That's BY. If you add all together, and this is now your third vector. Again, if you're solving this geometrically, you need to use a ruler. So this is now our vector C. If we are again dealing vectors with components along x and y only. So that's our vector C. That is by adding its components. Another approach is what we call a parallelogram method. Kanina, we determine C, we arrive at C by using the components, adding the components of the vectors. Here, we could do this. For parallelogram method, first thing you should do is you add the vector, you need to extend the vector. At the end of vector B, you need to add a line that is parallel to vector A. Also on vector A, you have to extend a line that is parallel to B. Again ha, there is a B, extend ka og line that is parallel to A. At the end of vector A, extend a line that is parallel to B. If we are going to use a ruler here, we expect that at the point of intersection of the extended lines is where the end of vector C. So again, using parallelogram method, we could determine vector C. Another approach is what we call head to tail method, but it's similar with parallelogram method. Here it is. If you try to look at this line is actually having the same length as vector A. That line. In fact, that is equal or identical to vector A. This line. This is vector A. As you could see, based on that illustration, geometrically, we could still determine vector C by simply adding this because this is vector B. Vector B plus vector A. Vector addition follows commutative law of addition. Another way of looking at the illustration here is if you try to look at this extended line here, this is basically the same length as vector B and it has the same direction with vector B. In fact, this is equal to vector B. Call that vector B. If this is vector A and that's vector B, then we could say that vector C is just equal to vector A plus B. And what we did is just using the head to tail method. What we mean is that we added the tail of the second vector. If this is our second vector, in this case, this one, the second vector is A. The tail of the second vector is connected on the first vector, the head of the first vector, and then we could trace back from the tail of the first vector to the head of the last vector, or in this case, the second vector. We could still determine the resultant vector. In this case, it's vector C. Also, in the same manner as we could determine vector C by using A plus B. That's how you could do with head to tail method. But again, the two approaches, the parallelogram method and the head to tail method, are geometrical approaches. Hence, you must use a ruler. The scaling must be accurate. You need to use a ruler. And now the next question you would be asking is what's the direction of vector C? Given the vectors A and B, what do you think is the direction of C? So this angle alpha, that angle alpha can be determined using protractor. So gamit kang protractor, measure nimo dire, sakdo nimo na pila ang angle ana. That would be the angle that indicates the direction of vector C.